we looked at the identities for the sum and for the difference. In the green bubble here are your identities for the sum and difference, identities for sine, cosine, and tangent. We graphed this in your calculator. We put this in our y1, we put this in y2, and we found out these guys are not equal. So you can't distribute through your parentheses and end up with the same outcome there. We put this in the calculator, and we found out both of these graph the same graph right on top of each other, so they are equal. So even though distributive property doesn't work, expanding this using the cosine of the first angle, cosine of the second angle, minus the sine of the first angle times the sine of the second angle, does give us a value that's equal. And that's basically how we came up with all of the identities listed below in the bubble. So if we look at a couple examples in class, we did the first two, so we'll look at the second two here. So if I have cosine of 120 minus 45, if I use my cosine identity, which is, this is my first angle, this is my second angle. If I expand that, it would be cosine of the first angle, cosine of the second angle, plus sine of the first angle, sine of the second angle, which is angle B. And then we can fill in the values for these. Angle A is 120, angle B is 45. And then if you draw a couple of triangles that represent these angles, 120 degrees is an angle in my second quadrant. It's a 30, 60, 90 triangle. That reference angle is 60, so the cosine for that triangle is negative 1/2. Cosine for 45 degrees, that's in my first quadrant. So cosine of 45 is 1 over root 2. The sine for 120, I'm back at this first triangle here. The sine is root 3 over 2. And the sine of 45 degrees is 1 over root 2. And then multiply a numerator times numerator, denominator times denominator. We get negative 1 over 2 root 2 plus root 3 over 2 root 2. And I can put that together as one big fraction there, with a common denominator. And just like we looked at the graphs, you can see that example 4 is not going to be equivalent to this first fraction. We said you don't have a distributive property. We can't do this, distribute the cosine through the parentheses. So that's what it looks like has happened here. If I find the value for this, the cosine for 120 using that first triangle there is negative 1/2. The cosine for 45 degrees using the second triangle is 1 over root 2. If I find a common denominator of 2 root 2, multiply top and bottom by root 2, I'll have negative root 2. Multiply top and bottom by 2, I'll have minus 2. You can see these two fractions are not equal. So just using the identity to expand. Then we could use those identities to find some of these trig functions as an exact value, even if the angle is not a special angle. So if you look at something like, let's see, we'll do sine of 165, the second example here, number 6. I want to find a value, instead of 165, I want to find two special angles that I add together and get 165. Well, if I try 100 plus 65, that does add up to 165, but neither of these are special angle measures. So let's try something like 45 plus 120. If I add those two together, I get 165, and both of those are special right triangles. The 120 is a special right triangle in the second quadrant. So if I graph that, it's negative 1 and root 3 and 2, and that angle's the 120 that puts me in that second quadrant. And then 45 again, these are the same two triangles I had on that first page there. So the sine of 45 plus 120 is sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. And I can expand that and fill in the ratios using those triangles there. So sine of 45 is 1 over root 2. Cosine of 120 is negative 1 over 2. Plus the cosine of 45, which is 1 over root 2. And the sine of 120, which is root 3 over 2. I'm multiplying these fractions together. I have a common denominator of 2 root 2. I have negative 1 plus root 3 for this one. If you're given an angle that is in radians, like for number 8, you can just convert this. Multiply this together. You have 5 times 180 divided by 12. We'll convert that to degrees. And 5 times 180 divided by 12 gives us cosine of 105. And then 105 you want to write as the sum or the difference of 2 special angles. So I'm going to use 60 plus 45. All right, in 60 degrees, I don't have a triangle here, so I'll draw one. 60 degrees in this first quadrant here. You have 1, 2, and root 3 for my sides. So expand your identity on the right here. It's cosine of the first angle times cosine of the second angle, and it's the opposite symbol in between. Sine of the first angle, sine of the second angle. And then filling in your ratios from your triangle. Cosine of 60 degrees, using that first triangle there, would be 1/2. Cosine of 45 is 1 over root 2. Sine of 60 degrees is root 3 over 2. Sine of 45 is 1 over root 2. And multiplying these fractions together, I have 1 minus root 3 in the top, 2 root 2 in the bottom. Tangent for 15 degrees, just be careful. Tangent is undefined at 90 degrees, so you could never use 90 degrees for this. We could use 45 minus 30. We could also use 60 minus 45. And both of these values give me tangent of 15 degrees. So I'm going to erase this triangle a little bit here, just have a little bit of space. So if I pick one of these two, I'm going to pick this second one here. Tangent of 60 minus 45. So tangent of my first angle minus tangent of my second angle divided by 1 plus the product of those two. And the tangent for 60 degrees, it's this first triangle right here. I have root 3 divided by 1. Tangent for 45, I erase that triangle, but that's going to give me 1. And in the bottom, then I have their product, so root 3 times 1. So I have root 3 minus 1 in the top, and 1 plus root 3 in the bottom. And you don't have to rationalize, you can leave it just like that. And then finally, the last couple examples in this first set here, they give you the expanded side. You have to condense it down to a single trig function. So if you look at the pattern that you see here, you have a sine and a cosine plus a cosine sine. That follows the pattern for sine of A plus B. The sine of the first, cosine of the second, plus cosine of the first, times the sine of the second. And my two angles then for this would be 110 and 80. So this is equal to the sine of 190 degrees. These problems are just a way to help you to kind of memorize the identities. There's really no practical purpose for these problems. This one, if you're looking at this pattern here, it's tangent of A minus B in the top, and then 1 plus tangent of A times tangent of B. So it's the difference identity for your tangent. So it would just be 152 minus the 47, and 152 minus 47 looks like it gives us 105. Right, and that's all they wanted you to do with that, just expand those. So now here's a couple of the homework problems that we'll go through and do together. So evaluate the sine and cosine of the tangent for negative pi over 12. So what you could do for this is I would probably convert this right away into degrees. So negative pi divided by 12 is negative 15 degrees. So think of it as that. So I have sine of negative 15 degrees. So I want to add or subtract two angles that will give me negative 15 degrees. So if I pick something like, I could do 45 minus 30. Oh, sorry, the other way around. 30 minus 45 would give me a negative value there. So the difference identity for sine would be sine of 30 cosine of 45 minus cosine of 30 sine of 45. And if you have, I'm going to draw these triangles over here because we can probably reuse them for the next one. So 30 degrees, that would be 1, 2, and root 3. And 45, if you still need to see the triangle there, 1, 1, and root 2. So the sine for 30 degrees is 1/2. Cosine of 45 degrees is 1 over root 2. Cosine of 30 degrees is root 3 over 2. Sine of 45 is 1 over root 2. So you have 1 minus root 3 all over 2 root 2. We could do the same thing for cosine. We could do the same thing. We'll do the tangent one because that one, I guess, is a little bit different. So cosine, I could do the same thing, 30 minus 45, and expand the identity. Let's look at tangent. So this would be tangent of 30 minus tangent of 45, all over 1 minus the product. Right, and then 30 degrees, the tangent is 1 over root 3. Tangent for 45 is 1. And this would be 1 minus 1 over root 3 times 1. So for this one, you end up with a complex fraction. Just multiply top and bottom by the thing that's causing the complex fraction, which is at root 3. So if I distribute through the parentheses, I'll have 1 minus root 3 in the top, and I'll have root 3 minus 1 in the bottom. And then the same thing for negative 7 pi over 12. I would write this as a angle in degrees first, which would be negative 105 degrees. If you don't like the negative angle, you could always find a coterminal angle for it by adding or subtracting 360 if you like. I'm going to leave it as 105. So let's do for this, we didn't do the cosine in the last one, so let's do the cosine. So two angles that add or subtract and give us 105. I guess we could use, I don't know, negative 45 plus negative 60. So you could do plus negative 60 if you wanted to, or you could just make it minus and use the difference identity. I think I'll leave it this way, two negative angles. So I have cosine of the first angle, cosine of the second angle, and it'll be a minus because I have a plus sign in between, sine of the first angle, sine of the second angle. And then I don't have a triangle with a negative 45 and negative 60 degrees, so I'll just draw it right up here. So negative 45 degrees is down here in the fourth quadrant, and then negative 60 degrees also in the fourth quadrant. So that'd be 1 and negative root 3 and 2. So the cosine for 45 is 1 over root 2. Cosine of negative 60 degrees is 1/2. The sine for negative 45 degrees is negative 1 over root 2. And the sine for negative 60 degrees is negative root 3 over 2. Let's be careful of your plus and your minus signs here. So I have 1 over 2 root 2 for that first term. This negative and negative would cancel and give me a positive, so it's going to be a minus still. And it would be root 3 over 2 root 2, which is that same fraction we keep coming up with. 1 minus root 3 over 2 root 2. I could do the same thing for the sine and for the tangent, expand the identity and fill in those values there.